Okay, I'm not confident that we understood the domain completely, so let me just start from square one and maybe it'll make more sense. Okay, when you are talking about the domain of an odd root, your domain is all real numbers, and I'll explain why. We can take the cubed root of positive 8, which is 2, or we can take the cubed root of negative 8, which is negative 2. So anytime you have an odd root, we can have negative and positive x values, right? So that would be all real numbers for odd roots. However, if you have an even root, for example, the square root, we can take the square root of positive numbers, but you can't take the square root of a negative number. You guys know the answer is imaginary, but it's not a real number, right? So there are no two numbers that would multiply together to give us negative 16. Yes, there's imaginary numbers, right? 4i times 4i will give us negative 16, but there's no real numbers. So we can't take the even root of negative numbers, and therefore our domain for even roots is all the x values that are greater than or equal to 0. So that's the basis. So let's start there. Okay? Then the only other additional thing that you have to consider is a denominator. Okay? You guys know you can't divide by 0, right? If you have a line and you are calculating the slope and you get 9 divided by 0, your slope is undefined. And if you guys take calculus, you'll talk a lot more about that. But we can't divide by 0. So you have to take out the x values that are going to make your denominator 0. You have to take them out of your domain. So in this example, what x value would make this 0? Negative 2 would. If I plugged in negative 2, then my denominator is 0, and we can't have that. So we would have to say for our domain, we would have to say that x cannot equal negative 2. Now, when you say, so for example, which one was it? Oh, I don't remember which example it was. If you have an odd root, actually, hang on, okay, so that was in our notes. That was like this example. Okay. We had 4x divided by x to the 2/3 power. So 3 is your root here, right? So this is an odd root, which means your domain would be all reals, but we can't have our denominator be 0. So what would make our denominator 0? Well, if x was 0, then our denominator would be 0. So it's all reals except 0, since that would make our denominator 0. So another way that we can write this, all reals except 0, is we can just say x does not equal 0. And that implies that it's all reals except for 0. Okay? So that's what that means. And then I gave you guys 2 additional examples. Okay? One of them looked like this. 4x divided by x to the 1/2 power. So x is an odd root, so that's just all reals. And then in the denominator we have, it doesn't matter that's in the denominator, but we have an even root here. So you guys know for even roots, x has to be greater than or equal to 0. So we cannot plug in any negative values for x since we have an even root here. But also, we can't plug in 0, otherwise it's going to make the denominator 0. So instead of saying that x is greater than or equal to 0, we also have to remove 0. So now x can only be greater than 0 for 2 reasons, right? For one, because that's an even root, and then because they're all positive, right? Because it's an even root. But then we also had to remove 0 because it would make our denominator 0. So there's our domain. And I'll just talk about one more. 3x to the 5/2 power over negative 9x to the 1/3 power. So this is an even root. So already you know that you have to take all the negative x values out of your domain, right? So since it's an even root, x has to be at least greater than or equal to 0. Down here we have an odd root, okay? So that would be all reals, but it can't be all reals anymore because we have an even root. So therefore we can only have positive x values. But you always have to check, are you dividing? And we can't divide by 0. So what x value, or what x value would make this denominator 0? 0, right? X cannot equal 0, or else my denominator is going to be 0, and we can't divide by 0. So we have to remove 0 from our domain, and so our domain is just all the x values that are greater than 0. I hope that makes sense.